no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Sorry, let me get this working correctly. Expand that out. Start the event. There we go. Boom, 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 boom. Okay, welcome everyone to Office Hours. Streams, we help you out with math homework, science homework, all sorts of fun stuff today. Let's see, why is my chat's doing some weird stuff? Excuse me. Let me fix this. I don't know why it sees two. It's Rust Wipe Day. Oh, does this mean you have to play Rust now for like the next the next 24 hours? Because everyone starts with like new stuff or something, right? That's always fun. One second, I need my thing to work correctly here. Pretty much, nice. It's a cool concept when games do that. I know Tarkov does that, right? They every couple months, just to make sure that like people who have been playing the game for a while don't stay on top, and to, I guess, encourage new players to join because they're not going to get stomped. They reset everybody's items, I think, and like do they reset everyone's stats as well? I guess you probably have like a lifetime stats thing. I feel like, yeah, everything gets like reset. Alright, I'm gonna activate this one. I don't know why it's displaying two. Fuck it. Let me see. Is our chat working here? Test. Yes, that's working. Okay, cool. But yeah, pretty chill day today. I need to finish up grading. I let the students in my UCLA class submit requests for like regrades. So by default, we give them like a lot of partial credit, but sometimes they made like a really silly mistake, or you know, they see like, oh, you know, I should have put a 1 here instead of a 0, or I put a plus instead of a minus. And so I give them like another opportunity to like go through their work, see what they did wrong, and then like write me a little report, and then I give them more points. But I need to go through all those requests because I think the deadline for them is tonight, for them to submit it. And then I got to start submitting final grades over the weekend. So I'm not completely done with this UCLA thing, but I'm not teaching anymore. And Office Hours is still kind of chill. Yo, what's up, Alistair? College is kind of killing me? Yeah. That'll happen. Why is college killing you, dude? College should be fun. I mean, it's definitely work. You gotta put in some work for sure. But it should be fun as well. What's up, Pinhead? Are you experiencing the, what is it? The Waterloo effect? He says yes. I feel like there was a really good like thread on all these. Oh, I don't want to open Instagram though. Can I just open like the page, please? Oh, it's gonna make me open it. I don't want to open Instagram. Oh, that's really. I'd like to open this just in the browser. There we go. Okay, now I can see it. Yeah, students share their progress from year 1 to year 5 in engineering school. Year 1. All the happiness leaves their face. I think the common thing here is that people start growing beards. You see that? Like no beard, beard. I think that's kind of like the common thing. No beard, beard, no beard, beard. You're experiencing hell with eigenvalues? Oh, let us help you out, dude. It can be tedious for sure. Solving all those quadratics. Yeah. You know, the presidencies do this as well to people. Stress definitely takes a toll on the body. You can see it. Gold, did you learn how to code by yourself? Yeah. I taught myself C++. Using this book. And keep in mind, like, you guys live in, again, like the golden age of learning anything, because I guess it's a double-edged sword, right? Because AI can write code for you, so you go through less of a struggle of trying to write code yourself, and definitely go through less struggle trying to figure out, like, debugging. Debugging used to be such an art form, and it was very tedious, and it was very painful to, like, write this code, and then you have to go figure out, oh, where did I miss, like, a semicolon or something, or why is my thing not incrementing correctly? But you got good at, like problem solving, and especially, like, when writing code, you wouldn't write it all at once. You would write it in, like, chunks, and you'd be like, does this chunk work? Cool. All right, let's go write more. Does this chunk work? Cool. Let's write more. And then, like, along the way, eventually you'd be like, okay, cool, it should all work. Yeah, all the little details. I just say the funny thing is, now with the advent of AI, any of these debugging errors, you can literally, I've done it before. I've just sent, like, code that isn't working. I send it to AI. I'm like, why isn't this working? Instantly, it'll be like, oh, this. You need to fix this. I'm like, damn, that's cool, but it kind of takes the fun out of it. And the learning process. But yeah, this is how I learned C++, was this book. I remember reading this book on a road trip from Texas to California, Houston to LA. Or not LA, sorry. It was like Orange County. We were going to go visit my aunt and uncle. And I was just in the back seat of my 15-passenger church van that my family drove, because I had 5 sisters, or still have 5 sisters. And yeah, it was like a 3-day drive, so I just read this in the back all day. But like anything, reading books and watching videos and doing tutorials, that'll only do so much for you in order to really learn coding. I say you need to do things. You need to do things with code. You have to have a reason for learning the code. It's the same thing with, like, foreign languages and stuff. Nice, 75 stream streak. Good job. Good job. Taco, I think our record is 100. Let's see if you beat 100. So yeah, I say I taught myself C++ from this book. I didn't really code much in C++ though, because this was me in, I want to say, like 8th grade, 9th grade maybe. What I really learned how to code in first was called TI Basic, which was writing programs on my calculator. So with the TI-84, the calculator I show you guys all the time when we do stuff on the stream, you can code on that calculator. It's pretty tedious. It's very brutal, because you have to, like, manually scroll through things, and you know, this is the screen you get. It's not very big. It's a very small screen. But yeah, if you ever want to, like, program on this on the calculator, I would make, like, little role play, like, RPG games and stuff. It was super fun. But yeah, you would go to, like, what was it? Oh yeah, program, new. I don't even think I could write a program right now. I forgot it all at this point. But yeah, you'd make a program, and you'd say, like, oh, let me call this, like, program, like, and also the keyboard here is terrible, right? It's not even QWERTY. And then here's your program. And so it had all the standard stuff: if, then, else, for, while, repeat, input. I think maybe we could do this. I think we could say, like, input X, and then the next thing you could say is, like, I don't know, X plus 3 implies Y, and then I think you can say, like, display Y. Maybe this works. I don't even know. I don't even know if this works for, like, writing code at this point. And then I know you had to have an end in there, right? Yeah, you always have to have an end and end the code. Which country is this stream? US, yeah, Los Angeles. So now if I go to program and I run this, oh yeah, see, cool. It says like put in a number. Let's put in 5. It already got mad at me. I think you don't want the end actually. Sorry, I think this is it. But it's very tedious to code like this, and by nature of it being basic, it's not object oriented, which means you have to use a lot of like go to commands, like go to this line, go to this line. Yeah, this where is it? Yeah, go to. This like label would tell like where in the code things were, and then you would have to tell your code manually to go to certain places. Very tedious, but it was cool. So that's how I first started to, I would say, actually implement doing things with code. And that like really ignited my curiosity for it. I then took Java in computer science in high school, and that was cool. That was like my first like probably real language that I coded in was Java. And then from there, I had some other things I did for work in like Visual Basic or VBA, Visual Basic for applications. So that's like basic, but like for like controlling Excel and things. And then, yeah, I did a lot of IDL coding in grad school. And so IDL is like a coding language for data analysis. And nowadays, I really just use ChatGPT to write Python. Because it's just so easy, it's so fast, and it doesn't really make mistakes very often, and when it does, it can figure them out. So, but I think it really helps to have learned how to code before AI as a youngin, because you develop a skill for like how code should be written, like the overall structure. And also you can debug things if stuff isn't working. So if ChatGPT writes like this really big thing of code for me and I want to change like one little thing, I know where to go find it, and I know what variable to change, or like what loop I need to like fix. So Visual Basic is an IDE. No, Visual Basic is a language for sure. I'm pretty sure it's a language. Yeah, VB code. It's Microsoft's form of BASIC, but it also allows you to do like GUIs and things. You're right. I mean, it is also, IDE stands for Interactive Development Environment, and so it's also like a program you can use to like create windows and GUIs and stuff. So yeah, it's all cool. I highly encourage students to learn how to code. Even though you may not be a coder per se as your occupation anymore, with the advent of AI, it still builds up some great skills that are really important for other problems. I used to code via Python and TBH. My programs are still sitting there. Now I'm just trying to learn what I put there. This is why you should always document your code. I know no one wants to document their code. But yeah, always document stuff. Document means like when you're writing your code, you can like, usually it's like 2 backslashes or like 2 apostrophes, or I think I think it's ampersands in Python maybe. But that's things you write that the program ignores, but that you as a human can use to like understand, hey, that's what this part of the code does, or like this is the point of it. So yeah, go. I definitely encourage, go learn some coding languages. They're fun. Yeah. That's the best you can do, Alistair. Yeah. Yeah. Cool. All right. This is gonna be the last stream of the week. Yeah, I do gotta move my calendar around a little bit. I will be leaving Friday for a music festival. I'm gonna go have some fun. And so, as a result, we won't have our recess games on Friday. I'll do something fun for you guys next Friday. Don't worry. And then I won't be around on Sunday either. I'm getting back Monday afternoon. So hopefully we still have a stream Monday evening. I'll let you guys know how I feel. I'm wondering what programming languages to learn next, especially as a comp sci student. Python's like one of the most, useful ones, I guess. Everything I think these days has some sort of Python derivative of it. If you want to become like really like niche specific useful, I think like COBOL is another language that a lot of old banking systems are all written on, and they need people who understand how to write it. So, but those are like antiquated, like super old ones. I don't know. I mean, like if you just like learning coding languages to learn coding languages, another very useful one is JavaScript for sure. So like web coding stuff is really important. I generally abhorred web coding just because it was hard to test. Like you need like a server or something. The nice thing about like Python is you could just run like the local compiler on your PC and you can see really quickly whether something runs or not. With web coding, you have to have like a server set up, and then you have to like upload the code to the server, and then like for me it was always like a little bit more tricky to do. It's definitely, it's tricky probably as a student if you don't have money to. I pay for servers. I have servers that host things like the actual office hours website and stuff. But yeah, if you don't have a server that you can play around with, it's kind of difficult to learn how to web code. So. Anyways. All right. So yeah, that's all the news. Looks like we got some questions in the queue. So let's help you guys out. Have some fun. And let's kick off the stream. All right, welcome over to Actual Education Office Hours. My name is Dr. Gold, streaming healthcare, math, and science homework. All sorts of fun stuff today. Let's get TikTok going. We didn't, in fact, win tons. What does that mean? Excuse me. What are you saying?
There's a monument called military tunnels.
Military tunnels.
We went. Yeah, we went to go run it, and a team of about 8 people came up and just viciously touched us.
Touched you? Like where on the doll did they touch you?
In the bad places.
In my no-no square? No, that's my no-no square.
Yeah,
Don't touch me, my no-no square.
Yeah, we got halfway through running it, and then about 8 people pushed us.
This is Rust, yeah?
And then, yeah, and we killed all 8 of them, and then they came back 8 of them again. So there was not a whole lot we could do there.
I thought when you respawn, you don't respawn with anything, though, no?
No, but you'll have like a bag in your base, so you can spawn in on your base and then grab, a re-kit and then sprint over and fight again.
Live to fight another day. Here, let's do this one real quick, and then Breskles, you want to do yours next? Because no one else is really saying stuff.
Sure, man.
Yeah, cool. This one looks fun. I want to start off with something like gentle, because I'll admit I'm a little hungover from last night.
That's understandable.
My friend who's he's like the brewmaster of one of my favorite local breweries. He had his birthday party last night, and it was pirate themed, so there was lots of rum and tequila, and I was like, oh man.
Oh, understandable.
Such as a Wednesday.
Well, not the tequila. Tequila's rough. I haven't done tequila.
I think if tequila's rough, you're drinking the wrong type of tequila. My friends have become obsessed with like these craft tequilas now.
As in the actual flavor of it. Now, granted, I only drink like Patron. Really, it's the only
Patron is decent
that I like. But no, I mean rough as in I make really bad decisions.
Truth, yeah. That's like
I remember one time I was drinking Patron, I was Patron, and my homeboy went to go hook up with this chick in the guest bedroom, and so me being as fucked up as I was, they had like 20 or 25 foot vaulted ceilings in their house there.
Oh no!
So I took a nail gun. And I took I took a nail gun.
Why is your instinct to start picking up power tools?
Because the plan was we took their boots and their hat and we stapled it to the top of the roof, and then we threw it over the fence into the UPS complex next door, so that they had to go like drunk as fuck without their shoes search through this UPS complex.
You're such a good friend.
Ladder. Oh, I know.
I mean, this is hilarious, this story, but like, the questionable decisions, dude. I'm wasted. Let me pick up a nail gun.
It was pretty funny. It was actually really funny.
So here's the funny thing. Do you document any of these things, or these just like live rent free in people's heads?
I think I have a photo of it actually.
Yeah.
Let me check.
Narosky, what's up, dude? The vampire's back. Yo, Narosky, long time no see. What's cracking, dude?
A lot actually.
Ooh, tell us. Give us the update. What's going on in life?
So, I'm going on an international competition soon, which is pretty cool.
International Math Olympiad, is that what it is?
No, it's mostly IT based. It's not like math.
Okay.
But like, so cybersecurity, right?
Yes, pen testing and stuff, right?
Yeah, and what I'm supposed to be doing in my team is cryptography. So basically math, but for other people it's not math. You know?
I got you.
So
that's very cool.
I'm the only one. Actually, I'm one of two people in my team who are supposed to deal with cryptography. So we're basically just like math majors in computer science.
What's the name of the competition? I'm just curious if I can like research it or something.
The European cybersecurity competition or something.
Cybersecurity. I feel like you would love going to DEF CON. Have you heard of DEF CON, right? Out here in the US?
That's a bit more difficult than
Yeah, it's these are like the elite hackers, right? DEF CON, these people are nuts.
Yeah, if DEF CON, well no, actually if Europeans is high school, DEF CON is like PhD.
Yeah, I have some buddies that go to it. I think they do more like the entertainment side of it. They're like providing like the DJ parties and stuff. But I've heard this is such a wild event. I want to go to it at some point, just to be around it, dude.
Yeah, I mean, if your team is not formed out of more than 30 people and you score top 10, in DEF CON, you are probably on a watch list somewhere.
Oh. Yeah, like the CIA or the KGB is like, who is this? Who is this?
Like if it's not a massive team who's just brute forcing everything, then like you're definitely being watched.
I love this, dude. No recording glasses at DEF CON. Metastyle glasses are prohibited. DEF CON's one of these funny things. I've heard like people go to this it's a conference for hackers for those that don't know. But they go to this conference and then like all their credit cards just get like stolen just for like the fun of it. And people will but no one's like being like malicious. Like they just hack for like the fun of it. They're just like, "Oh, I got all your shit. Like look at this."
Yeah, exactly. It's so cool.
It's fucking wild, yeah. Okay, but cool. This is
I couldn't find the shoes on the roof, but this was the same night.
Dude, what is that dude's chest tattoo? Excuse me?
I don't even remember.
Y'all look like... Is that a Second Amendment flag on the right, too?
Yeah. And then on the other side, it doesn't show it, but you can see the wall on the left. That wall had a Confederate flag on it.
This is the most like Southern American thing I've ever seen.
Yeah, well, this was actually in Colorado.
Oh, this is Colorado. Oh, interesting. Okay. Yeah, this is what we call good old boys drinking their twisted tea and
Coors Banquet.
The banquet beer. It's the banquet beer. Beautiful. It's hilarious. But nice, Narosky. This looks fun. Cool. 10 best talents aged between 14 and 25, which is held in... So where are you going? Oh, you're going to Germany this year?
Yep.
Oh, sick. In Bochum. I don't even know where Bochum is. Bochum, Germany.
Honestly, I have no idea either.
Yeah. What's up, cool dude? Let me see what you're close to.
I think it's a small city, yeah.
Yeah, it's next to Dortmund, I guess. Dusseldorf. Oh wow, cool dude.
Oh, it's close to France and stuff, yeah.
Yeah, Belgium, yeah. There you go. Okay. Cool. Well, that'll be fun. You get to go on a trip as well, man. I assume it's kind of sponsored at least, right? You get at least some.
Oh yeah.
Oh hell yeah. Fuck yeah, dude, that's cool.
Yeah,
And
I went to Austria as well, because you know how national teams of sports go to different events when they're
Yes.
called upon?
Mm-hmm.
Yeah, we did that, but for cybersecurity, right? So I went to Austria, I think maybe 2-3 weeks ago.
Yeah.
Yeah, on a boot camp. So yeah, and my team is gonna go in Serbia soon. I opted not to go because I have a lot of stuff going on in August. So
yeah, you're still in high school too, right?
yeah.
He's like, I'm still in school. Oh, I see. And so these are the countries. So the gold medal was. Is this Italy? Italy was the gold medal last year.
Italy is pretty strong. Yeah.
I didn't know the Italians had good hackers. I felt like all the great hackers are like Ukrainian or like Bosnian or Serbian or something. No? Or just all the illegal ones are, I guess.
Yeah, I feel
Not
like they're
even,
kind of like in it.
Funnily enough, I think Denmark
with them, when they don't stop a hacker, they actually like cap casualties. So I think they have some skin in the game in that sense.
I get it. Yeah.
Well, I think we would be seeing a lot of more skewed results if we allowed Russia to participate, but they aren't allowed to participate.
Yeah, they say this about
we did win. Romania did win 2019.
Okay, well, I'm looking for it. Oh, there you go, Romania. There you are. Yeah, there it is. Wow, that's super cool. What's the problem? Sorry, like what do they give you? Do they give you just like a server and they're like, hey, hack this, or is it? I'm just curious, what the challenge is.
I don't want to speak on behalf of like my other teammates because I'm not an expert, but mostly in cryptography, you're given like a series of output text for a program. So let's say the author of the problem made a Python program or a C++ program. Using a modern encryption system with a critical vulnerability in it, and he gives you the output text of that program. So he inputs something in it, he encodes it, and he gives you the output. What you're supposed to do as a cryptographer is look at the code, see where the problem is, write an attack script, and try to deobfuscate the mathematics behind the.
So you like reversing the hash.
Code.
Kind of, right?
Pretty much, yeah.
Well, that's pretty cool.
Yeah, because the most common one, I don't know if I think you've heard of it, maybe at least, RSA encryption.
Yeah, RSA, of course, RSA keys.
Yeah, like low public exponent, for example, using a low exponent is easy to brute force. Stuff like that, yeah.
This used to be the first, like, two-factor authentication. I remember having one of these when I was at Los Alamos. Like, before they were on phones, you would literally get a key like this, and it would flash these numbers, like, every, 5 minutes or something.
Yeah, fun fact about RSA. RSA literally stands for the names of the people who invented it.
Ah, that's pretty cool. Nice. See my chat real quick. Coolest dude said, so basically I took an accelerated program because I really wanted to. After some underwhelming performance, I'm having a hard time deciding whether to continue or just let it be. I assume by let it be you mean like drop out. I don't know what let it be means. But maybe let me know what the IB program. Okay, cool. Well, I mean, I would always take the IB test at least at the end of the day, right? What IB program is it? Did you ever feel like giving up on your major? Yeah, of course. Yeah, all the time, dude. What? but that's part of the perseverance. You just have to keep going. Yes, I think anyone who's in a difficult thing that is worth it goes through periods of feeling really demotivated and disheartened and why am I doing this? It's part of the process. But for the answer, coolest dude, I say if it's not going to hurt your record, there is definitely, for instance, in classes they have what's called a drop period, where up to a certain point in time, you can drop the class without it showing up on your transcript or like showing up as a negative thing. So usually you want to have a conversation with the professor to be like, hey, like, you know, when is the drop period? Like, when can I drop this without consequences? And like, honestly, do you think I can get there? Because I'll tell students that come to me in my class, I'll give them the honest response of like, yeah, you got a 20 on your first exam, you got a 30 on your second exam. It's not looking good. Like, you'd need like a 90 on the final, and I don't really think you're going to get there. And then I tell them to drop. But if, you know, they got like a 70, then they got an 80, and like, I'm like, yeah, it's possible. So I like to be very realistic with things. So I would say talk to your professor. Ask them what the consequences are, like when you can drop. And I am usually in favor of being perseverant and sticking with it till the end. Just keep going. Yeah. Yes, AP Physics, yes, go take AP Physics. Great class. All right, let's try to do this question. This one's from Pinhead here. I forget. Narosky, have you taken like differential equations or anything?
Oh yeah, of course.
Oh, nice, okay. I remember.
How are you taking Diff-EQ and not calculus?
No, I think he's taking calculus by now. You've taken calculus, Narosky, by now, right?
Yeah.
Yes. Okay, there you go. Cool.
Oh, so, yeah, then yes.
It used to be he hadn't taken calculus, but he had taken linear algebra before calculus, which I think,
to be fair, you really don't need calculus for linear algebra until you get to least squares methods.
I agree.
Yeah, I think the math structure in Romania is well structured.
Mm-hmm.
Well, I really didn't speak English there. I think the way it's put together is like really thoughtful for students. But it's sad that most students in Romania don't really focus a lot on school.
Why? What do they focus on? Like cigarettes and vodka?
Yeah, pretty much.
Oh no!
Honestly.
Oh no!
Like, I live in a bubble. I look around and in my high school even, which is a prestigious school. I'm not opposed.
You go to a good like magnet like high school, yeah.
Yeah, I do, and even in this school, I see like students just not giving two craps about their grades or anything. Like, they don't have a future plan. They don't have anything.
Interesting. Why do you think that is?
Complacency, maybe.
Okay. Like they're like it's good enough. Yeah,
they feel like they have a backup and whatever.
Oh, I see. Like dad owns the concrete steel mill and they can just go work there if they need to or something.
Yeah.
Yes, I will say having no plan B will really motivate you to have a plan A. If you have like a safety backup, you're like, yeah, fuck it, I don't really need to do this. Gotta burn the bridges, dude. Okay, how do I do this question though? Sorry. The eigenvalues of the coefficient matrix can be found by inspection or factoring. Apply the eigenvalue method to find a general solution of the system. So is this a 3 variable differential equation?
Yeah. So you'll want to set up the matrix, figure out the eigenvalues and the eigenvectors of the matrix, and then get the general solution from there.
Oh, so is this what we call a system of differential equations?
Yeah. So it's like the same as what I had given like earlier in the summer when I was taking advanced Diff-EQ. It's just
Okay. What's the matrix I set up? I'm just curious.
So it's all of your coefficients in a 3x3 matrix.
Okay.
Right. So like x1 has 7, so it'll go
7, 2, 2.
7, 2, 2, yeah, and so on and so forth.
Oh, I think I see what's going to happen here. Negative 12 minus 7 minus 2. This is 12, 7. And then this is technically multiplying, right, by x1, x2, x3.
Yeah.
And then it needs to equal dx1, dx2, dx3, right?
Yeah, so you would just say
the derivative of x, yeah.
Right, so like this, yeah? Is this correct?
Mm-hmm. Yeah.
Oh, that's fucking cool. Okay.
Oh, sorry to interrupt.
No, you're good.
I wanted to input for the mathematician or the mathematic.
Yeah, the mathematician guy, yeah.
Yeah. If you want to improve your English, definitely check out Cambridge. In general, look up. I'm gonna post a link in chat.
Yeah, post it. I'll pull it up. Yeah, actually, I've had a couple students actually asking my chats, like, how do you get better at the English SAT? And we recently learned that the English SAT has passages that are a maximum of 150 words. I was like, what? It's like super low attention span stuff. They're very short passages. So the SAT, the reading section or English section, whatever you call it, used to be like these page-long things you needed to read, and then there would be like 10 questions about that page-long passage. But they've evolved it to now the passages are a maximum of 150 words, so they're a lot shorter, and then they only have like 1 or 2 questions about it. Yeah.
Well, this is definitely overkill for what you want, but if you want to improve, definitely check out Eng Exam.
Eng Exam. Oh, okay, cool.
Oh, CAE. Sorry, out of
you know
all
what's
these,
funny?
CAE.
CAE at UCLA stands for Center for Accessible Education, and they're like the bane of my existence because it's all the kids that like claim they have like anxiety and they can't do things on time and they need extensions, and I'm like,
you're not that guy.
Stop.
Yeah,
Okay.
and if you scroll down here, you're gonna see like CAE C1 Advanced.
Yeah.
I don't agree with C2 Proficiency. I think those are way too difficult, especially for SAT.
Do you think I could even do these?
But,
I
mean, it's not for someone who is like you have to fill in the words.
You got you fill in the missing words.
You choose if. For
wow,
example,
manifests, exhibits, unveils, and divulges. Only one of those is correct. Those are that's like the same fucking word, dude. What?
Yeah, but you gotta know which one to use correctly.
I feel like this one would be
definition.
manifests. Yeah. Oh wow, that's pretty tricky, dude. That's tricky.
Yeah, and this is C2. C1 is more friendly.
Okay.
Per se.
I see. And I do think
every level.
Yeah, every level.
Sorry.
You're good. No, you're good.
Every level, for example, if you decide to take B2 first, it's gonna have some notions of C1, right? You are not just taking B2. You're gonna have some C1 advanced level stuff.
Yeah. I see. Oh, this is fun. Man, that's super cool.
This is the listening part.
Oh, that's cool. Okay, cool. Yeah, go check that out, mathematician. I do find
anything that's reading and writing, use of English, whatever, that's helpful for you.
That's a great resource. Yeah, a lot of the SAT stuff seems to be knowing like which word to use. So a lot of it seems to be like vocabulary based and getting a sense for like context. Like if the context is this, I use this word. If the context is I use this word. Alistair says, bro, college is so ass. Why do the subjects actually related to my course have less days in my schedule than other subjects?
You're not that guy, pal.
I don't know, dude.
You're not that guy.
I don't know, dude. It's okay. So, sometimes the course is not related. The subjects not related to your... The subjects not related to your course are to build up other skills. So it's okay. All right, let me see what this is Pinhead's question, though. He says, I think the way we've been doing it is subtracting lambda on the diagonal. I have not been paying attention to any of my prof's videos. That's gonna be problem number 1, dog. Anyways, so this looks like, right, some matrix A times, I want to say like an eigenvector, right, is equal to ddt of v.
You would just say like x bar, right? Because it's not technically an eigenvector yet.
Okay.
You would just say like, normally we say ax, and then ddt of x.
Gotcha. Because the classic one, right, is that like ax is equal to like lambda x. Is that what this is? This is the classic eigenvalue.
That's for eigenvalues, but for the general system, you would just say that it's any system of ax equal to some matrix or to some b. Its eigenvalues satisfy that equation.
Okay. So I just need to find the eigenvalues of this first. It's kind of the start. Okay, let's do it. Yeah, this is a bitch.
Oh no.
Fucking 3x3 eigenvalues, dude. No. Why? I don't want to do that. Yeah, but okay. So this question, I guess, we're going to solve this. We're going to say that, like, A lambda equals B lambda. And so, what is it? It's A minus lambda I equals 0. I know that. I want to remember, like, where this comes from.
No, it's the determinant of A minus lambda I.
That's what it is. Yes. Okay, you're right, Narowski. Yes, the determinant of this is equal to 0. I forget why this is, but but okay.
Do you want me to explain why?
Can you give me like a quick explanation for why it is? Sure.
No.
Oh no.
Okay then. Here, we'll do the explanation later then. I just want to keep moving on it. JE, I'll ask your question in a second. I don't think I was smart just because of genetics. I do think there is some sort of genetic. This is like a really hot topic. People get really upset about saying that like intelligence isn't genetic. I do believe some bits of intelligence are genetic, but the types of intelligence, it's different. It's different. Okay, I'll describe that later. Let's do this one. All right, so this is 7 minus lambda 2 negative 12, negative 7 minus
Might
lambda.
be able to save some effort too by doing row operations first.
Ooh, okay.
If you do row operations, you're gonna get a lot of 5s and negative 5s.
All right, let's do that. Okay, let's do some row ops. Brescals has a good idea, right? Because if I add this one to this one, right? So if I do row 3 plus row 2 implies row 2. Then right off the bat, right, I have 7, 2, 2. And then I have 0, 5, 5, right? And then this is still 12, 12, 7. I mean, I guess that kind of helps it a little bit.
I would actually first do some row operations on row 3. Because if you add row 3 to row 2 before you do that, you'll get rid of that bottom left corner. And then you can do the same row operations.
Or you want to add row 1 to row 2, I think. Is what you said, right?
Row 3 to row 2, and then you can do
row 3 to row 2 becomes what though?
Well, you would at least get a 0 on the bottom row, which at least when you do the determinant gets rid of one term.
Oh, you want to do row 3 plus row 2 is row 3. Is that what you're saying?
Yeah.
Okay, cool.
I guess you could do it with any, but at least there you're guaranteeing saving yourself at least one difficult term.
Yeah. Oh, okay, there you go. JC's got the one sentence solution. Yeah. Oh, AV equals lambda V rearranging. Yes, okay, that's what it was. It was you get rearranging. Yes, A minus lambda. Yeah, okay, one second. Let me just write this out real quick. AV equals lambda V. This is the classic eigenvalue question. You move that over. You get AV minus lambda V is equal to 0. You can pull the V out. And so you get V A minus lambda is equal to 0. Uh-huh. Right. Which has a non-zero solution for V only if the determinant of this is equal to 0. I see. This has to equal 0 in order for this to equal to 0. Got you. Okay. And then this becomes A minus lambda I. Yeah. Gotcha. Cool. All right. So, Einstein was so selfish that he didn't marry one. I'm pretty sure he did marry people. Which means he didn't share his genetics. I guarantee he shared his genetics. But yeah. They have Einstein's brain. I think they when he died, they donated it to science. I don't think there's anything super special about his brain, actually. If you remember, like, Einstein was actually kind of regarded as, like, not a very smart person at the beginning of his life. Some argue that he really wasn't that smart. He just was really good at putting the ideas of other people together, but... Yeah, he married his cousin, yeah. Yeah, he did some weird shit.
So Einstein was just AI before AI?
He was.
Good job.
Because if you recall, like, Einstein was, like, blatantly wrong about quantum mechanics, right? He got such an ego about relativity that he was like, oh, I must be the best. And then he was just fucking wrong. He had 3 children. Okay, so he did have
Yeah,
kids.
I think it was Newton, I think, that died a virgin.
Yeah.
Really? No way.
Yeah.
Yeah, he died.
As far as I'm aware, he
Died a virgin, dude. Wait, how old was he? Like 50?
I don't know.
He just
I
said,
guess that's what happens when you invent calculus.
yeah, he's just like, I have no desire for the pleasures of the flesh because I have invented the universe. That's fucking funny. Oh man. Okay, I don't know if I want to make this simpler because then I'd have to start multiplying this by like sevenths and stuff, you know? Do we
Well,
want
you
to
could
do
add
that?
you could add row 2 to row 1 and then make that row 2. And
Yes. Good. You're right
then
about
add
that.
row 1 to row 2 and make that
Wait,
row
wait.
1.
I think I want to add row 1 to row 2 and make that row 2, right?
Mhm.
Okay, yeah, sorry. Let's get this out of here. So again, we are trying to make our life a little bit easier, Pinhead, by doing some basic linear algebra row operations so that we have an easier 3x3 to work with. I wish I had good genetics. You do have good genetics, dude. What? You just got to figure out like what your genetics are good at, you know? Sometimes like trying to put the square into the round hole, square peg in the round hole, it just doesn't work. I think everyone is naturally gifted at something. It's just you got to figure out what that is. Sometimes it isn't math, but that's okay. All right, 7, 2, 2, -5, -5, 0. Oh, look at this. Look at all these 5s. And then, oh, this is cool. I'm pretty sure I'm doing this right? Yeah, 2 and -7 is -5. Yeah, cool. But now I can add this one to this one, right? Or no, well, actually, wait. Oh, I guess it depends like
You
where
could,
I want the
but
0.
I mean that probably. Yeah, I mean
want-
that's probably already saving you enough work. I'd feel like.
Yeah, I feel like it will.
So
Yeah, I
we
mean,
already cut out at least 2 terms.
Yeah, I could add this to this to get rid of this 0, but then I end up getting rid of this 0. Whatever. Let's just leave it
I'd
like
just
this.
leave that 0. Because if you leave that 0, then it just becomes.
Well, I guess.
the determinant.
Well. Yes. Okay. This is only going to be a quadratic, anyways, right?
Yeah, it shouldn't be. Too
Wait,
bad.
will it? No. It'll be a cubic.
No,
Because-
it will be a quadratic in this case.
Well,
'Cause
this
if
will
you
have.
do it with respect to the bottom row,
Yeah.
right? The first term becomes 0.
All right. Let's see. Okay. So let me do this. I'm gonna say like minus lambda, minus lambda, minus lambda. And so if I do the determinant of this, right, that's going to be 7 minus lambda times, right, this. So this becomes...
So what I'm saying is, instead of doing the determinant for the top row, do it for the bottom row. Because instead of multiplying by 7 minus lambda, you're multiplying by 0, and then it's just...
Oh, you want to... Oh, that's so wacky. You're doing this.
Yeah. Because that allows us to have
this
the
is what you're doing.
0 eliminated term.
Oh. Okay, so okay. I'm going to just switch row 3 and row 1 then. That's what I'm going to do. Just to... Because I've never done that. I guess it works, right?
Yeah, it's a legal move.
It's a legal move. But yeah, okay. Swap row 3. I see why this is tedious, Pinhead. I see why this is a tedious question. Okay.
If you swap rows, do you not need to add a negative sign?
Ooh! Do you? You're the linear algebra expert, Narowski.
I mean, this is what I remember off the top of my head.
If you swap
Yeah,
rows...
that's why I was just going to do it with respect to the bottom one, so I don't have to remember the specific properties. And I don't remember doing that would affect specifically
if
the
I
A minus lambda I
swap
matrix.
rows in a matrix. Do I
No,
have
I think
to-
it was just when you do determinants. I think that's what I'm remembering.
Yeah, let me just see. Okay. One swap, multiply the old determinant by -1. You're right.
Yeah, that's with determinants, but I don't think we're... Oh, we are doing determinants.
We are going to do a determinant, though. That's the issue, yeah. Yeah.
Yeah.
Oh, that's more
I'm
tricky.
so tired. I just spoke without thinking.
Oh no.
You're good, dude. You're good, dude. Alexandria says, I'm currently studying aerospace engineering. Congrats. At UCLA. Cool. I teach at UCLA. Can you help me with a math and physics problem? Yes. If you want to submit a question to our queue, the website for it is here. It's called actualofficehours.com. Here, I'll put it in the chat for you. And just drop a screenshot in there. And it'll get added. And we'll go through it. Okay. Okay, I swapped this. So determinant will be negative. Okay, and now let's just do the determinant. So this is minus lambda, minus lambda.
Well, but then we lose that term. I want to say it should go bottom left to top right.
Bottom left to top right.
For the diagonal of lambdas.
Oh.
Because we're
You
doing
think I need to do this way?
I mean, you could. I that's why I was thinking it, because you still have a negative lambda term that you got to multiply by, right? That's why I was saying that we should just do it from the bottom, because there's still a zero term there.
Oh man, okay. I might just like plug this into something. Just tell it.
I usually don't use
I don't know why we overcomplicated this.
Yeah.
To be fair, I could have done it
something
faster.
earlier, but yeah.
Okay, fuck this. All right,
I didn't say anything.
It's okay. No. Let's stop being complicated. let's just stop. Okay, it's okay.
Like we can do a 3x3 determinant.
We can do it. The American in me just didn't want to
do it, or
yeah,
not the same.
Yeah, I just didn't want to do it, but it's okay. Fuck it. Let's just do it live. Okay. So I'm going to do the determinant of this minus lambda, minus lambda, minus lambda. And let's just see like what like big fat mess that becomes. So that's going to be 7 minus lambda times negative 7 minus lambda times 7 minus lambda. And then that's going to be plus 24. Oh, ew, this is so gross. Okay, fine. Okay, and then we're going to say minus 2. And then that's going to be negative 12 times 7 minus lambda. Plus 24 again, I guess, right? Yeah. It's the same 12 and negative 2. Okay. Oh, at least that one wasn't so bad, because this just has one more lambda in it. Got you. Okay, cool. And then finally plus 2. And then that's going to be negative 24 plus 84 lambda. Okay. Is this not a cubic now, guys, though?
No, it is.
And I have to solve this whole shit equals 0, dude?
Yeah.
Oh, man. Alexandra, are you married? Dude, JEE, chill, dog. No. I swear the second there's like a girl that comes in my chat, some of the thirst traps come out, dude. Chill, dude. Don't just ask random people on the internet if they're married. They already said they're in college, too. No one's really married in college. Chill.
You'd be surprised.
Some people, yeah. I mean, you know, if you go to like a really Christian conservative college,
not even Christian and conservative. I know this one chick. Not gonna lie, kind of a total hoe, but she was already divorced by the time I met her, still in college, and then she has since gotten engaged to someone else.
Wow.
Within like
she's speedrunning,
2
dude.
years.
Speedrunning the relationship thing. That's crazy, dude.
Yeah. I don't know what's up with that.
I don't recommend that. JEE, god damn it, these kids, dude. All right, I gotta take care of you, JEE. I'm not gonna add you as a moderator. Okay. All right. Man, this is a mess though. Negatives. So I have a minus sign. 7 minus lambda, 7 minus lambda. I just don't like this. Whatever. I'll just leave it. Negative 7 minus lambda. And then plus 24. 7 minus lambda. And then this is equal to, no, sorry, minus 48 plus 24. Oh, at least this is kind of like looking a little nice.
I guess you could also save yourself some effort if you pull out that negative on the 7 minus lambda. Because then it becomes 7 plus lambda. And
on
that's
this
the
one?
difference of perfect squares. Yeah.
If I
becomes
pull
the difference
this,
of perfect squares.
right, and say this is 7 plus lambda, yeah, you're right. I could do that.
And then you'll get a 49 plus lambda squared there.
Yes.
That
Okay.
might make things a
On
little easier.
on this one, yeah. Well, one of these will mix with one of these, I think, right?
Yeah, and then you get a 49 plus lambda squared, and then that's all multiplied by the
By 7 minus
7
lambda.
minus lambda, and that at least.
And they have a 7
makes
minus
some of
lambda.
the-
Oh man, if only I had a 7 minus lambda on here as well. Then we could just like divide them all out. That'd be so nice. Okay, minus 48, and then this. And then this is minus 48. They said aerospace engineering, and then plus 168 lambda. That's all equal to 0. Okay. This is just a mess, dude. I don't really want to do this. I'm just gonna have ChatGPT do this.
You can just like ask it for the.
I just want the eigenvalues, right?
Yeah.
Give me the eigenvalues. Please. What's up, Fembox? Yeah, so what you would do here, Pinhead, is you'd have to multiply this all out. It would turn into a cubic. You'd have to figure out what one of your roots was by using whatever that method's called, rational roots theorem. And then you'd have to divide by it and then get a quadratic, and then you'd have to solve the quadratic. It's a lot of steps. Yeah. Oh, nice. Cool. Yeah, we do a lot of homework help. Yeah, Alexandra. I mean, yeah, we're a live stream. We do... Dude, what? The eigenvalues are 7, 5, and minus 5? That's actually kind of cool. Okay. Let's wrap this one real quick.
7 was to be expected because the entire diagonal is 7s.
Got you. Yeah. Oh, I see. Well, it was 7s and minus 7s, I guess. Yeah.
Yeah, and that's why the minus 5 shows up, sorry.
Okay, so we would say, solve the cubic. And then what would I do from here once I have the eigenvalues?
You solve for the eigenvectors. So for each one of those, you'll solve a minus lambda I multiplied by the vector b is equal to 0.
Dude, is this really what you guys have to do?
Yeah.
By hand?
Oh shit, not good.
Yeah. There's
Dude,
some methods that make it like slightly easier. Like sometimes you can get lucky with like a matrix exponential.
This is brutal.
But yeah, it's generally just like this by hand.
I don't know if this like
And then it
teaches
gets
you
worse.
anything other. This just teaches you like hate math.
I mean, yeah, it depends on like who the instructor is. Like I had 3x3 matrices, but they were never this.
One sec, I gotta
Right? And it was
I gotta
never
get rid of all these
complicated.
kids, dude. Dude, one sec, give me a second here. You guys are in timeout, dude. Okay. Yeah, it does suck. It does suck.
There is a nice way to deduce the functional equation that you need to solve this, and I think I just stumbled across it. I wasn't looking at it properly before.
Okay.
I'm gonna write it down because it's a lot simpler.
Cool, thanks. Alexandria, no, I apologize. This channel's not usually weird, but sometimes, every once in a while, we get like weirdos that. I'll give you a little bit of advice for being a girl on the internet, because it is unfortunately a terrible place if you're a girl, because dudes hide behind keyboards and say like whatever fuck shit they want. You should just have your username just be Alex, and you won't get harassed by like a bunch of like thirsty fucking weirdos. I try to do the best I can to moderate those people out, but it's the reality of what we live in. So I promise we're not weird. It's just sometimes weirdos show up, and they are not representative of me or my community. They just find me sometimes. Okay, so this would be 0. This would be minus 14. This would be 0. And then this needs to get... You mean some of us... I mean, yeah, being weird is fine. Being creepy. Sorry, that's what I want to say. Being creepy is not cool. Yeah, being creepy. And I don't understand, like, why these dudes think that being creepy is going to get them anywhere. That's always my... You know, you always see the classic, like, hello, you have nice bobs. I love you. Like, will you marry me? Like, dude, what? No girl's going to respond to that.
Oh, no.
Are you retarded? I think they just troll. I think it's honestly what it is. But it's better to practice trying to be like a normal person. This is also 0. Okay. No, we have plenty of girls on our well, I would say this is the first time on YouTube Shorts that a girl with a girl's name has like shown up. We have a lot of girls in our Discord. Yeah. I've tons of don't worry. Like, but it is a rare thing, I guess, on the internet that I know a lot of the girls in our Discord or in our whatever, they do purposely like hide their usernames as being girls because unfortunately, again, as I described, like dudes are sometimes just creepy, just weirdos. I get it. It's an unfortunate reality. All right, but this needs to equal... What does this need to equal again? Oh, what the thing... Wait, which is
vector.
The derivative. Does it need to equal the 0 vector?
Yeah. When you're doing eigenvalues and eigenvectors, it's the 0 vector.
Okay. Yeah,
Unless
all
it's
right.
a repeated eigenvalue. But
So
we don't have any
2v2
of those.
plus 2v3 is equal to 0. Dude, this sucks!
Oh, no.
Dude,
You
no!
could actually... No, you could pretty easily get... an equation, you could get v2 is equal to 0.
Well,
by
I guess
adding-
you get v2 here is equal to negative v3 though, right?
Yeah, and v3 would also be 0.
Yeah.
Because if you look at the third equation, if you add row 3 to row 2, you'll get 0, 2, and then 0.
Yes, I see. 0, 2, and 0. I see. I mean, just from this, if v2 equals negative v3, and then this is plus 0, v3 is equal to 0. Right, yeah, the only solution... Wait, the only solution here that works, sorry, is that, oh, man. v2 equals negative v3, so that means v2 equals 0.
That just gives us...
No, wait, no.
Wait, no.
one second.
No,
You're not
yeah, I
that
forgot
guy,
about the
trust me.
negative 2.
You're not that guy.
Yeah, v2 is negative v3. Okay. So that means...
Here, I'm gonna... sorry for going quiet. Here's
No, you're okay.
what I
You're
came up with.
Yeah, let's see.
This is what I came up with.
You can call me Dr. G, Alexandria, or Dr. Gold, or whatever you want. That's my name. All right, let's see. If v does not equal 0 is an eigenvector to A corresponding to the eigenvalue lambda, then AV equals lambda V. X prime A equals AX prime A, X equals X1, X2. We're looking for the solutions of the form XA is equal to FAV. If we take
for some
derivative-
function f.
For some function f, okay. So if we take the derivatives, X prime A, which we said was AXA, is equal to
Yeah.
F prime AV, which is then FAV. Oh, this is clever.
Yeah, and then we have a functional equation for f. F prime of a is equal to the lambda of
Lambda of F of A.
yeah, lambda f of a. Yeah,
Oh, so I don't even need the eigenvectors?
I think you do at some point, but this is like the
Yeah, well, and if it's asking for the eigenvalue method specifically, this would be how you would get
Oh, is that what they said?
wizardly. Yeah, I think it said using the eigenvalue method.
Dude, what 7th layer of hell is this Diffie Q class? Yeah.
Judging by the fact that it has an online...
Oh, it said like apply the
Students.
eigenvalue method.
Yeah.
yeah.
Any of these online sites are just like, yeah, how many fucking
Yeah.
coefficients can I put in here and how difficult can I make it computationally to figure out?
It's just so mean, dude. Here, okay.
Yeah, well, if you know like how to solve different differential equations, like finding what functions f prime of a is equal to a constant times f of a. I mean, it's just going to be something exponential anyway.
Okay, let's see. Okay, let's say we could solve all the eigenvectors, which I think we got close with. We got close with this one. I knew it was at least v2 and v3. How do you figure out v1 is -1 though? Oh, I guess if you make these, if you assume this is 1 and -1.
Yeah.
Oh, okay.
Normally because we're going to have a constant C1, right. You can simplify it to whatever is going to be a convenient.
I got it, and then v1 would end up being just 1. Group world is who I use. Okay, cool. All right, let's just say we did this. Okay, so like find solve for the eigenvectors again. Blah blah blah. Takes a while. All right,
yeah, it's just row operations. What first equals is trying to do.
Yep. Okay. So once I have the eigenvalues and the eigenvectors, how can I finally solve this thing for the general form?
Yeah. Once you have your eigenvalues and your eigenvectors, it's just the sum of your solutions, right? So you'll say C1, your V1, and then your e to the lambda t.
Okay. So it's C1 times. Oh, I got it. 1 minus 1, 1, and then this would be e to the 7t plus C2. Oh, okay. -1, 1, 0. E to the 5t.
Yeah.
And then plus C3. 0,
The general
1.
solution is, yeah, I didn't know this general solution. I just like solved for it in the screenshot I gave you.
I see.
I didn't know it was a general, like you can see that.
This makes sense though. Yeah, right.
It's just gonna be c times e to the power of lambda a.
Yeah, exactly. Right? Because that's the only way you get this to come down.
Yeah, and then x of t, like our vector, is just f of t times v. So that's
Pinhead
where
says
the vector comes in.
I didn't think you could row reduce before putting lambda in the matrix, but I could be mistaken.
I forget exactly. I usually don't do it to begin with because
you just like love pain.
Not well, just most of the time it's not like a lot of like computation because you could just make it 3 different linear algebra problems inside of one differential equations question.
Right.
But it's not a linear algebra class, it's a differential equations class, so
okay.
They achieve much.
So I would hope on an exam, Pinhead, you don't need to do this by hand. Like, this is just brutal. This is mean.
Oh, the vector. I just realized why ChatGPT chose the vectors the way it did. It's because they have to be independent. I don't think it even calculated them. I think it just guessed and checked if they were independent.
What channel is this? This is a channel we help people out with math and science homework. Okay. So, Pinhead, does this make sense the way we did it?
Question, yeah.
Yeah, it was a cool question. Thanks for it, Pinhead. It was a long one, but
Also,
I learned how much I detest like. It's just like yeah. This is kind of whack. It's whack. They make you do that, dude. It's so much work. It's like I know how to do the things, but just like doing it to a 3x3 is just ugly. I guess you needed to, right, to have like some fun systems of equations to solve. Whatever.
Well, I mean, there are ones that aren't that ugly that are 3x3s. That one is.
I see. Like a 2x2 would be more chill, probably.
Well, if you don't make it ugly, somebody's gonna find a different way to solve it.
Versus doing that method.
Well, but I mean that making it that ugly doesn't. I mean, because that's the easy method to solve it. Like that's the standard, like generally easiest. And most of the time they just make it so that when you take the determinant, like it doesn't become some ugly cubic. They just make it so that like certain.
Oh, I see. Some things like drop out nicely or something.
Yeah, different terms like cancel, and you don't have to do all the like.
Oh, thanks for the donation, Pinhead. Sorry for the sins I have committed against you all. You're fine, Pinhead, dude. Thanks for the $5, dude. I appreciate that. That's cool. Oh man, I heard that India's a really dude. Now Alexandria is a troll account. Alexandria, chill. What's up with? You know what I think it is? I think it's that mathematician guy who just keeps creating YouTube accounts to just like troll my YouTube chat. Oh man, India's not.
To be fair, that's real. What she said is really tame, considering anything that Sensation says.
That is true. That is true. Yeah, where's Sensation, dude? I need Sensation would deal with my YouTube chat.
You would have a field day.
He'd have a swift hand against it. All right. Let's see. Let's Brescals. Let's do your question. Let's do yours. This sounds fun. Am I going to use Feynman's method here? I feel like this is going to be a Feynman's method
Indeed.
question. Yes! I love Feynman's. Narosky, do you know about Feynman's method?
The one with differentiating under the integral sign?
Yes.
Yes.
Yes, it's so cool. It's so cool. All right, let's see. Derive a more general form of this by differentiating with respect to A. That is, show that I of A is equal to pi over 2 absolute value of A. And so 7.61 is a special case. Oh, they gave away the farm, dude.
Oh, no.
They just told us everything. They told us how to do it. That's no fun. Oh man. Okay, fine. Usually, I like to challenge myself to figure out what I need to do for Feynman's, like what derivative I need to take it with respect to. I guess with respect to A makes the most sense. Okay, let me see if I can do this myself. Okay, sine squared. Yeah. What'd you say there, Brescals? Cut out for a second.
Oh, I said all right.
All right. Yeah. So this looks like a weird integral. I don't know how to integrate sine squared over x squared. Do I know the integral for sine squared normally? I wonder if I do actually. India's a place filled with someone's trying to get my channel like banned by slandering India. Chill, please. Oh, maybe you do. Oh man. Yeah. I feel like this becomes a double angle thing, right? Sine squared.
Yeah, I think that's usually what you do.
That's usually what you do. Yeah. You convert sine squared of x into a double angle, and then you integrate it. Okay, that's how we do it. Got you. Okay. So, yeah, I could do that. The issue is the x down here is screwing things up. Disqualified. I don't like this here, right? Because then I think I'd like to maybe do like a u sub or something. Okay, so in that case, Feynman's trick is.
Why can't we just differentiate as it is? Sorry.
No, we are. Right, we're gonna do this, right? So I'm gonna do DDA here, and then I'm gonna do DDA here. But the cool thing about derivatives and integrals is I can bring that inside, and I think this becomes a partial.
In terms of x, no.
Interesting.
No, because it becomes problematic because your integrals with respect to x. The advantage of Feynman's trick is that when you do that, your ordinary derivative comes into the integral and becomes a partial derivative. So you can just set the parameter arbitrarily and then pick a specific value of the parameter that is like really convenient for you to solve your problem, and then do simplifications by taking that derivative.
Yeah, I think I see the issue here. If I did the derivative with respect to x, that would kind of like mess up this as well, right? We don't want to do that. I would do the ddx if there was an x up here, then I would, right? Because ddx would just like would kill this all off and everything would be happy. All right, so this would be di dA is equal to integral from 0 to infinity. Oh, okay. So now the derivative with respect to a, I see what this is going to do. So, oh man, this is kind of a couple funny rules here. So first, I'm gonna leave the 1 over x squared out, not out front, but more forward because I don't really care about it. So the derivative of sine squared. So that's 2 sine of ax. Right? 2 sine of ax cosine of ax times a. No, times x. All over x squared. Did I do that right?
Yeah, you already wrote the x squared term. Like.
Oh, I already did, yeah. Okay, cool. 2 sine of ax cosine of x times x. Okay, so one of these will cancel, which is nice. And I feel like this is an identity. Wait. 2 sine of x cosine of x. Yeah, that's a cool one. I know that one. Well, I thought I knew it. One sec. Trig. I want to say... Is it sine 2a? Yeah, right?
Yeah. That's the fun thing about when you differentiate the sine of n to the power... Sine to the power of n of any constant times x. It just becomes like... I'm not sure, actually.
Wait, you mean if like you did like sine... There's like power reduction rules, I remember, right?
Yeah, it becomes like n times sine to the power of n minus 1 times cos of, yeah. I think it was if it was an even power. I don't remember exactly.
There's one, yeah, I remember in calculus, I had to learn like, oh, if it's an even sine but an odd cosine, or an odd sine or even cosine or even, yeah. Okay, so this is very cool. So now this is 2 over x, and then that's going to be sine of 2ax, right?
I think the 2 cancels as well, because it's 2 sine cosine.
You're right, actually. Yep. Beautiful. Oh, this is much better now. Do I have to do another Feynman's trick, though?
Yeah, technically you could just use the cheat code and say that, like, oh, it's a Dirichlet integral.
Wait, but we can... This isn't absolutely convergent, is it?
Ooh,
I'm pretty sure it is.
Yeah, dividing by infinity, right? Should go to... Well, I guess because, like, 1 over n...
Yeah, well, sine of...
This doesn't converge, right? This thing wobbles. But I think the argument...
Sine of x over x from 0 to infinity is convergent.
But 1 over x, for instance... 1 over x is not, right? This is not convergent. So... Oh... Wait, yeah, wait a minute. Why is sine of x over x convergent then?
The short answer is it's a well-known and well-studied integral.
He's just like, just because it fucking is.
But then, how do we justify it?
Yeah, this is the Naroski brain going off.
Usually my justification is to say someone else in a book somewhere else justified it for me. Generally the way I solve it is by using Feynman's trick again.
I think we need to. Let's do Feynman's trick again, because this is the issue. Is that yes, sine of x over x is less than 1 over x, but the problem is like this diverges, so that doesn't necessarily prove that this converges by whatever like limit comparison test. So okay, cool. Good to see you, Alexandra.
Yeah, this integral just goes to infinity.
Oh dear. Okay, let's do another derivative then, maybe, right? Let's do DDA.
Why can't we do another one if we can't do the first one?
Well, just wave the hand, dude. I mean, yeah. Well, let's see. Let's see what happens.
Okay.
So d squared I over dA squared is now equal to 0 to infinity. And now this is going to be cosine of 2ax times 2x over x dx. Okay, so now this will cancel, and so I have d squared I. This is also not convergent though, no? Because I have integral from 0 to infinity of 2 cosine of 2ax, right? Or, yeah, wait. Well, I guess I can at least integrate it, but the issue is I'm going to get cosine of infinity, which is not really well defined, right?
Yeah, it's not.
Yeah.
It diverges.
This is going to, so this is dx. Let's see. So this would be 2, but then divide by 2. So 1 over a sine of 2ax from 0 to infinity, which, yeah, Narowski's right? This is 1 over a sine of infinity minus the sine of 0, but I don't care about the sine of 0. But what is this? Uh-huh. And so this is a special case of a is equal to 1.
Yeah, it's divergent because it doesn't settle on a value.
Okay.
So...
Wait, but how's this true though, dude? What? It says I of a is equal to pi over 2 times a?
Yeah, there are specific conditions in which the absolute value of this integral is convergent.
What?
Do we have to do it by Feynman's trick?
No.
I'm sure there's another way.
I think I see another way.
Okay, what's the other way?
Yeah.
I'm curious, have I done this correctly to this point though, by Feynman's trick?
Yeah. To that point, it's just that specific integral is.
Yeah.
Is infinity. Oh, it's a Dirichlet integral. Oh, sorry. Let me see what this is.
Yeah.
Oh. Ooh. Oh, okay.
Yeah, but now introduce A into it.
I see.
I actually don't think that A affects anything.
Because it's a
Yeah,
constant?
But how do you justify just multiplying the inside of the sign inside the integral? You know?
I see. You're saying here, right? This doesn't look exactly like this because I have a. But I guess in the case if a were equal to if a was equal to 1/2, wait, but they wanted a equaling to 1?
Yeah, it's the special case of a equals 1.
But if a equals 1, this becomes...
No, because you're looking at where we did the Feynman trick already.
Yeah.
Sorry. Oh, here. Oh.
Yeah.
Oh. Wait, but this is the integral of sine squared over x squared. This is sine of... Oh, wait, no.
What?
Sorry. What?
Yeah, so the original integral isn't the Dirichlet, but when we
Yeah, it's not.
take the derivative, it results in the Dirichlet integral.
Is this a Dirichlet integral, though? Because this has a 2a in it, in front of it.
Yeah, it's still a Dirichlet integral. All that really changes when you add the
okay.
is it
just happens
determines
faster.
the sign. Yeah, so it inevitably what ends up happening is it just changes from either being if a is negative, then you get a negative pi over 2. If a is positive, you end up with pi over 2.
Okay.
So my opinion is we can just let u equal to absolute value of a times x, and then we can use the Dirichlet integral.
You mean at this point right here?
No. And like
at the very beginning?
If we have the Yeah, at the very beginning, because you're gonna have sine squared of u.
Okay, let's see.
If you look closely, you're just gonna have it's visible even if you don't write anything, because you're gonna denote what's inside the sine squared by u.
Yes. Let ax equal to u. Okay.
Yeah. And you're just gonna have the integral from 0 to infinity of sine squared over u squared du. Because dx is just gonna be du over a.
Yeah, du would be sorry. Dx is equal to u over a. Okay, so I have a 1 over a out here then still, right?
Yeah.
Okay.
That cancels out because u squared is going to be over a squared.
Sorry. U squared is over a squared.
Well, no, actually, we can't do that, I don't think. Because u isn't ax, or the bottom isn't ax squared, or a squared x squared.
Right, dx is equal to du over a, so du is equal to a dx. Oh, wait. Fuck. Yeah. Okay. So I get to here. But yeah, the issue, this isn't a Dirichlet integral because this has an extra u squared on it, right?
Well, it is. No, isn't it just...
No, the Dirichlet is just straight up sine of x over x.
Yeah, I don't think it's sine of x over x squared.
I'm gonna argue that it is.
Alright, we'll see how it's defined.
I hope.
You hope. Oh, by Fubini's theorem. This is cute.
Oh yeah. Wait, I'm remembering now.
Are you getting there? E the minus xy of sine of x dy is the same thing as switching it and doing dx dy. And then wait a minute. Primitive of e to the oh, okay. Dude, what is this, dude? What is the primitive of e to the ax?
Primitive is just the... so you know how you say derivative?
Yes.
Or derivatives? Primitive is just the integral.
Oh, I didn't know that. That's kind of cool.
Because from what I know, the Dirichlet integral is defined for various values of n. If you have sine to the power of n over x to the power of n.
Okay.
But I'm not sure what the values are. And I'm hoping that it goes like n equals 1 is pi over 2, n equals 2 is pi over 2, and then it switches up. Because if not, then... whatever.
So this becomes like hieroglyphics for myself, dude. Yeah. Okay. So wait a minute. We were saying that at this point, right? That this is... so I didn't need to do this derivative? Or did I?
No, you were correct all the way up to the last step for that derivative. And then...
up to this one, so I don't need these ones.
Yeah, it just gets funky when you do...
I'm just going to say that this is basically this, which is... I'm just going to say di dA is equal to pi over 2 then. Right?
Yeah.
Okay. Because I get it. Whatever. Putting the 2a here, all that does is just like horizontally compress the integral. Which when you're going to infinity, what does that really matter, right?
Well, and I think also the a and the 2 would cancel out because if you say u is equal to 2ax, and then on the bottom you'd have x is equal to
u over 2a.
U over 2a, and then...
But then dx...
Yeah, dx would be...
du over 2a, right?
Yeah, and then...
So this would become...
Yeah, it flips and then the 2a cancels out.
Wait, this becomes sine of u. And then dx becomes du over 2a. Oh, okay. And then x becomes u over 2a. Oh, very cool. Oh, do you see that? Do you see that, Narowski?
Oh, yeah.
Yeah, okay. That's smart. Okay. All right. I feel better about that now. Okay, cool. All right, so then this is di over dA is equal to pi over 2, and that's it. So then I integrate, and I get that I is equal to pi over 2 times A. Okay. And then, oh, cool. Okay. Why the absolute value, though?
Probably because of the sign.
Probably because of the sign.
Because you need it to be positive or something.
Oh no, I see. Technically, I think the way the Dirichlet integral is defined with the A, it's
Oh, these are always positive.
Positive. It's negative pi over 2.
Yes.
For negative. So when we integrate, technically we're integrating pi over 2 times the sine of A, which would get us that the A value cancels out, or the positive and negative.
I also see from this, I mean, right? So this is an integral from 0 to infinity. These are positive numbers. X squared is positive. Sine squared is positive. Like, I don't care what the fuck A is. It needs to be positive. Right?
Yeah, pretty much.
Okay, cool. All right, cool. I learned some stuff. That's a cool question. Thanks, dude. Yeah, because the range is from 0 to positive infinity. I agree. Cool. I get kind of tired. I love seeing it. I can see breasticles in Rust 33 minutes. Is that going to turn into like 18 hours, dude?
Actually, probably not, because I have to meet with my professor at like 11:30 tomorrow. So
oh, okay. What are you meeting with him?
Probably
with?
not super long.
Are you doing like some project or what?
No, it's the end of my my independence study tomorrow. Tomorrow's the last day of classes, so I'm basically just gonna meet with him, go over any last minute questions, just running through.
What was your independent study thing on again? What were you doing?
Methods of applied mathematics.
Oh, cool.
So I basically it started with like some like linear algebra stuff, grad level linear algebra. Built like a foundation on linear algebra, moved that into function spaces and Sobolev and Hilbert spaces and all that, and then built into integral equations and then Green's functions and then calculus of variations. You built off of that.
Send us a paper when you finish it. I'd like to like try to read it. It'd be kind of cool.
Oh, I know. I'm not writing a paper on it. I'm just like reading through a book, doing problems. It's
just
okay. Like an independent study.
You don't have like a report afterwards? We would have like a senior thesis or something is what we would call it.
Well, it's not for like a thesis type of thing. It's just like basically the form. It's like your own class sort of. You just independently study stuff, and they just basically put on the form like, yeah, they were offering like a grad course, and then they dropped the grad course, and now he doesn't have anything to take over summer, so we're doing it and then study.
Okay. Okay.
Yeah.
No thesis, Fembox says. No thesis. No.
I'll do a thesis later.
Yes, do your thesis later.
It's not my thesis time yet, though.
It's not my time to thesis. Oh shit.
What's up with this your moment to shine part?
Dude, this is let's do one of these. You want to do one of these? This guy's always funny.
Yeah,
his name is Kaushik Techno. He always like puts like really fun like math challenge questions in my YouTube stream. Yeah, Kaushik, are you around, Kaushik? What's up, Kaushik? He's a funny guy. At first, like I really dreaded them because they were really difficult and made no sense to me. But lately, they've been like not terrible, and I've been actually able to solve them myself. So let's see. Let's do moment to shine, part 20. Oh, this is the hotel rooms. Oh man, I hate permutation questions though. I really do.
Well, it says okay.
Which one do you want to do?
Available.
You guys want to do you want to do the hotel room, Naroski, or the other one? Which one do you want to do?
This one's fine.
Okay, let's do this one.
I like combinatorics.
See, I don't. I wish I was better at them because they are very cool, but I'm just so bad at like converting like combinatorics to.
Well,
like
you just have to think of it like logically, no? You don't really have to think of it in terms of formula. I hate that. I don't like that either.
Okay. Yeah.
But if you think about it logically, just some of them just make sense intuitively. I mean, that's combinatorics in a nutshell.
Okay. All right, we got 4 rooms.
Yeah, 4
Right.
rooms, 6 people to be accommodated. So 6 people in 4 rooms, each room having 1 or 2 people.
Okay.
That seems simple enough, yeah. So
you have to have at least one
have,
person in every room, right? And then
yeah, so then 2 of them have to have 2 people.
have to float.
That's simple. Yeah.
The number of possible ways. Okay, so I feel like this is like 6 choose 4 to start, right? Because I have to figure out like fuck the.
No, you have how many double rooms do you have first off? 2, right?
Yeah, you have 2 double rooms, right?
2 double rooms. So out of how many people? 4. Out of how many rooms? Sorry, 2. So two double rooms out of 4 rooms, which is
4 choose 2,
which is 6. Yeah.
Let me see if I remember what that equation is, right? Is that 4 factorial over 2 factorial times 2 factorial?
Should be.
Yeah. Okay, yeah, so 12 over 2, which is equal to 6. Okay. So that's the double rooms, right? But then I also need who we put into each of the initial 4 rooms, right?
Yeah.
So is that 6 choose 4?
So wait.
Because yes, so the 2 double rooms is like picking which rooms, I guess, have 2 people in it. But then I'm thinking about like are these unique? For instance, is this like Amy? Is this Bob? Is this Charlie? And is this like
you're basically
Derek?
just permuting. Yeah, you're basically just permuting, but you have 6 people, so it's gonna be like Amy, Bob in one room, for example.
Right. Well, but then there's 2 other people, right? There's like Eric.
Yeah.
And Fred.
Yeah,
so
and you're trying to permute all of them.
Yes, exactly.
So,
right? Yeah.
So in your thinking, Amy can be with Bob, but she can be with Eric and Fred, and
Yeah. Yeah.
So
I just realized Amy's the only chick here.
I think. Correct me if I'm wrong, but I think an easier way, even than considering like double rooms, would be to pick 4 of them and permute them through the rooms, and then pick 2 of them and permute them through the rooms that have someone in it. Right? And say, in other words, rather than saying, let's choose 2 people, pick 2 rooms, and then let's pick the other 2 rooms. Let's say, let's put 4 people in 4 rooms, and then put 2 people in 2 rooms.
Yeah, I think we want 6 choose 4, right? So out of the 6, right? How many ways can I put those 6 people in where there's 1 in each room? And then there is 6 other combinations for how the last 2 people can be put into the double rooms, right? I think it's 6 choose 4 times 4 choose 2. This is putting 6 people into 4 rooms, 1 each. And then this is taking the remaining 2 people and having them occupy double rooms. I think. It always becomes like, is like the rooms picking the people or the people picking the rooms? Right, but let's see.
Yeah,
so,
I don't know.
Let's see. So 6 choose 4 would be 6 factorial over 4 factorial times 2 factorial, right? So then that would be equal to 6 times 5 all over 2. So that would be equal to 15. That seems low. 50. So 90 ways, that's it? Seems low.
No, that's low. No.
That's too low. Okay.
So, okay, well, if you want, I can like talk for a bit and
Yeah,
you can
talk for a
stop
bit.
me if you.
No, please talk.
Okay. So 4 rooms, 1 through 4, and 6 people, A through F, right?
Okay, I agree with this. So 1, 2, 3, 4.
Each room has to have a person. That's what we're being told. Has to have at least one person. So if we put one person in each room, we use 4 people and we have 2 left over. And they have to be put in different rooms.
Sure. So 1A, 2B.
So then, yeah. For
Okay.
example.
For example.
And we have 2 left over and we have to choose, like the first choice we make is where do we put these people? So out of the 4 free rooms, right now we have 4 free rooms basically for these 2 people. We have to choose 2 of them. So this is why I first did 4 choose 2. Yeah.
Oh,
right, so
okay.
the first choice we have
but
to
then
use
E
4
and F
choose
is different than F and E. Is I think what you're gonna say next, right? Like for instance, if I choose this room and this room to be, for instance, the 2 rooms that have doubles, putting E here and putting F here is unique to putting F here and putting E here.
Yeah, so twice 4 choose 2 basically.
Okay, 4 choose 2 times 2. Okay.
Yeah.
I agree with that. So that would be 12.
And now we have to just choose through A and B, for example. We have, where do we put A and B? So out of 6 people, we have to choose where we put A and B.
Just A and B? Why just A and B? Sorry.
For example, just A and B.
Oh, okay. I think we need to choose where A, B, C, and D go.
Any two.
Oh. That'd be 6 choose 2.
Yeah.
Okay.
Because we filled 2 rooms and the other 2 rooms are individual, and now we want to choose which 2 people go into the individual rooms. You know?
Oh.
Out of the 6.
Oh. Okay. I think I'm starting to get it here. So this is
because randomly at first every room has at least one person. That's guaranteed. The first choice you make is where E and F, for example, go. Or any 2 who haven't been chosen. Then you have 2 individual rooms. Which 2 people go in those individual rooms? So the second choice we have to make is 6 choose 2. Out of the 6, which 2 go into the individual room?
I agree with that. Okay. So these are people haven't been chosen. What rooms are going to be doubled? And then for the last 2, so for the 2 lonely rooms.
Yeah, basically.
You have 6 choose 2. But then don't you also have 6 choose 2 for the double rooms? Because I want to know. Wait, but no. Because when I pick who's in the lonely rooms, I've already basically said who's going to be in the double rooms.
Exactly. Yeah, it's exclusive. Yeah.
But I feel like I need to multiply this by 4. Because I need to multiply by 2. So for choosing the two lonely rooms, right? It's like, do I choose C and D or do I choose D and C?
No, because then we just have to choose. We make choices one after the other, right? So you can't just like, oh, I have to choose between this and this. No, you make one choice and then you make another.
Okay.
Right. So because we chose, so this is why, for example, it's useful to use examples. For example, we
I
used
see.
A and B.
This includes the permutations.
Yeah.
Got you. Oh, okay. Yeah.
Yeah, and now we have 4 people left who haven't been chosen. You know, so 4 choose 2. Again.
Oh, wait.
Yeah, because out of the 6 people, we already chose 2 for the lonely rooms, right?
The lonely rooms. Yeah. Okay.
Yeah, and we have to choose out of 4 people now because those 2 are fixed.
Okay, these are the lonely people. Okay. I think I see your strategy here. And then you have 4.
And then E and F.
4 choose 2. This is for the not lonely people.
Yeah.
And then this right here, 4 choose 2 times 2.
is the E and F, yeah.
These are the, let's say like the partners, I guess. Yeah.
Yeah, E and F or F and D, so that's why times 2. And this is every choice.
Okay, cool. All right, so we think it's 6 choose 2, 4 choose 2, 4 choose 2, times 2.
Yeah.
Okay, so 4 choose 2 is already just 6. So
yeah.
6, 6, 2, and then this is 6 times 5 times 4 times 3. All over 2, I think. No, I'm dumb. Sorry.
No,
it's 6 times 5 all over 2.
Yeah, which is 15.
Cool. Okay, so 15 times 36 times 2. So yeah, 30 times 36, which I do believe is Femvox got 1080. This kind of looks like 1080.
Should be 1080. Yeah.
Yeah, because
it's
yeah, just 1080. Wow. All right, Femvox 1080. Yeah, math is fun, buddy, dude. I love Kaushik, dude. Okay, cool. Kaushik, is the answer 1080? This buddy has some productive thinking. Yes. Yes. Kaushik, you haven't met Narosky, by the way. I don't think Narosky's been on the stream when you started seeing us, but yeah. Narosky's another fun lover of math and all things. Very intelligent. Cool. Correct. Beautiful. Let's mark that one as done. That one was done.
Yeah, and you see what I mean by trying to be logical about your choices when you do combinatorics. Like it's no formulas almost all the time.
Yeah. Yeah, it becomes interesting when there are things like if you're trying to, if there's like 6 things but you're trying to like pick like pairs of 2s and stuff, like they like divide by like 2 factorial, where it's like how many ways can I pick groups of 3? I love math loving people. Yes, nice. Yeah. Yeah, I think that's where I get into trouble with combinatorics is let's say for instance you had like, I don't know, 1, 2, 3, 4, 5, 6, and then I say how many like groups of 3 can I pick out? And it's like if they're like adjacent to each other or something. I don't know. Yeah, if you try to use formulas, you fall into pit holes. You just have to rationally think through those counting problems. Yeah, I agree. This is a cool way to think.
If you want, I also have a puzzle for everybody.
All right, what's the puzzle? We got 5 minutes left, but yeah, give us the puzzle. Maybe we'll do it later.
So,
what's up, Rebecca?
If, for example, you have a car in the desert.
Okay, I have a car in the desert.
And right below you, like on a 2D map, right? Let's say it's just 2D.
Okay.
At the bottom, you have your car and a reservoir of petrol. Let's say your car runs on petrol.
Okay.
If your car runs out of fuel before you reach the end, you fail.
Yes.
Your car holds, let's say, 200 kilometers.
200 kilometers of range. Okay.
Yeah. But you have to go 800 kilometers to get out of the desert.
Okay.
How do you do it?
I start pushing, dude.
Oh, that's easy. Yeah, that's easy.
Assuming
you push it until.
No, you can't get out of the car.
Oh, you can't get out of the car.
Okay.
You cannot
Option
get out
B.
of the car.
Option
And
B. You turn off the car.
you have an infinite amount. Sorry, let me finish the question.
Yeah, one sec.
Okay.
You have infinite what?
You have an infinite amount of petrol at your station, and you can leave petrol.
Okay. But sorry, and I can't leave the car, or I can leave the car. Sorry.
You cannot leave the car, but you can drop petrol off.
But I only have 200 kilometers of range.
Yeah.
Okay.
And 800 kilometers to go.
Oh man, dude. But I
Yes,
can
you go
drop.
like 100 kilometers.
Can I call? Can I call?
Drop
Can I call
off
the pet?
full tank, go back, and just keep going back. Just drop.
No, wait. How far away is the station?
It's just behind you. When you start, it's just behind you.
Oh. Yeah, Femox. Yeah. Okay. I think I get it. And I can drop petrol at different places. I can store it somewhere. Oh. Oh, okay. Is there like I guess is there a most effect? Okay, so this is like the gas station.
Yeah, this is the easy part of the question. This is like to understand it.
I got
the
you.
difficult part is what happens if you have a restriction on how much gas you have at the beginning.
So
Like
yeah, so I if I go 100, that's the maximum distance I can travel and that I can get back. But that doesn't do any good for me, right?
Yeah, you can't leave anything. You could ideally in this infinite gas world just go 99.
I could go 99.
Once,
yes.
or leave,
yes.
Yeah. And just be very inefficient.
Wait, if I go 99 and I leave 1. Oh, I would just need to do this like an infinite number of times to like build up whatever.
Because
like
you do have there is no time limit.
There's no time limit. Interesting. I see.
But what happens if you don't have infinite gas?
No. But even if I build up an infinite... Oh, I see. Because if I build up an infinite reservoir of gas here, now this becomes the new gas station, and then I just do the same shit, right? Oh. Oh, interesting. Dude, that's fascinating. This is such a cool question, actually.
Yeah, I had this as an assignment from... I do math with a professor that teaches children to think for Olympiad questions, and he gave me an assignment of come up with something you might see at a competition.
This is cool.
And this was my submission.
What was your solution?
I would personally stack up a bunch of gasoline and then light a cigarette, and technically the explosion would probably be big enough to get it.
I don't think it'd be big enough to get you to 800 kilometers, dude. Jesus.
Yeah, it's inspired from somewhere. Yeah.
I mean, I'm sure a particulate would eventually make its way out of the desert.
Yeah. Okay. So wait, what's the answer to this? Is the answer the just keep building gas stations thing?
Yeah, and the real question is something like
what's the most efficient way to do it?
What happens if you have like only I don't know, like 6,000 kilometers of gas or something at the beginning?
Mm-hmm.
Like what's the optimal? What is the least amount of gas you can start with?
I guess
basically?
this is where you could create a math thing, right? Because the most extremely inefficient case, right? There's edge cases, right? It's to go 99, but then there's also like to go 1. Right? If I go like 1 mile, drop off 200, come back.
Yeah, that's also inefficient, and going too far forward is too inefficient.
Yeah, interesting. Wow. Yes, the cow and the
most effective. Yeah, the most effective one is when you use your entire reservoir. You use it. I'm pretty sure it's something around like go. Maybe in this case, go 50, leave 100, go back 50, something like that.
Mm-hmm. Go 50, leave 100.
Or no, it's divided by 3, so 200 divided by 3 is the most efficient.
Oh, 66. Or 67.
Nice!
Yeah, go 66, leave however much, and go back 66.
Yeah, okay. I see, that's cool. What is your favorite in mathematics? Which topic is my favorite, Dr. Gold? I like calculus. I think calculus is really cool. I feel like this would be a calculus question because you're trying to optimize, right? Trying to maximize something.
Yeah. Yeah, and the real question is like find out how the least amount of gas you can start with to go 800 kilometers.
Yeah, this is cool.
Yeah, this is a fun riddle for the end of the stream.
Nice. Cool riddle. If you guys want to figure it out, I gotta go to a concert. Rebecca, cool. Sorry, what is this question, Rebecca? You gave me here? What? This is just what is this, Rebecca? Let me see. Sorry. This is just a lot of order of operations stuff, and then a cubic root, dude. Why? Is this supposed to be something funny, Rebecca?
I used to hate these when I was. We do this in 7th to 8th grade to just master quick calculations. Yeah.
Yeah. Well, let me do this real quick for her. So it's 81 times 10 to the 8th minus 1 times 10 to the 8th plus. So I would convert that into 10 to the 8ths, right? So that would be 1200 times 10 to the 8th, right?
Yeah.
Okay, and then this is all over 1 over 10 minus 9.8 minus 1 over 100. I don't think this is anything nice, right? That 9.8 is going to screw stuff. Oh, wait, this is 9.8 times 10 to the minus 2. Sorry.
That 9.8 looks like the gravitational acceleration.
Yeah, it does look like gravity, yeah, right? Yeah, this is 0.098. This isn't anything nice. I mean, this becomes 1280 times 10 to the 8th over wait a minute.
Oh, it does reduce.
It does.
That's dope.
Right? Because this is 0.10 minus 0.098.
You could rewrite that as I want to say 97 times 10 to the minus first on the bottom.
This one? I think it's 2 times 10 to the minus 3.
It is, yeah.
Right?
So
yeah, I mean that sounds accurate. I think.
Okay, so then this becomes
64 to the power of 12.
6. This is 640 times 10 to the 11, right?
Yeah.
Which
or 64 times 10 to the 12.
Beautiful. And then when I cube root this, cube root of this is now going to be 4. Cube root of this is going to be times 10 to the 4th. Right?
Yeah, 40k.
Oh, yeah, I love Warhammer 40k. Cool. Yeah, that's actually another fun question there. That's cool, Rebecca. I thought this was going to be really ugly at first. Yeah, 40,000. Choice A. That's a fun one. Rebecca, that's really cool. Here, Rebecca, I'll give you a coin for that. That was fun. Okay, cool. Let's end the stream. I gotta go. All right, thank you everyone for coming to Education Office Hours. Really appreciate everyone's input, all the education, the learning. I learned so much from you guys. It's really truly what keeps me young and like neural plasticity or whatever. Yeah, bye Rebecca. That's really cool. Yeah, thanks Narosky for coming by. This is fun too.
Yeah, of course. I'm gonna actually start streaming soon for anyone who's in Europe. So
please, yeah, let me know. Let's get you on the calendar and stuff.
Yeah.
I'll refer people to you for sure. I'll give you.
I won't be doing a lot of math stuff. I'll be doing like more gaming. But if anyone comes in with math, like of course I'm gonna do it.
Okay, cool. Yeah, let us know when you're streaming. Yeah. I'm always happy to support upcoming streamers, and you've done so much for us already. So like, I owe you one at least.
Oh, thank you.
Yeah, you're welcome. Okay. Do I do organic chemistry? I don't do organic chemistry, but JC does. JC used to stream. We need to get JC streaming again. My name is Jeff. What's up, Jeff? So yeah, again, the schedule for when we stream, actualofficehours.com. Go to the streaming schedule. I'm going to be out of town at a music festival this weekend, so no streams over the weekend or tomorrow, but then we'll have them back on Monday. So, oh, there you go. Nice. Yeah, Narosky has a girlfriend. No, that's dope.
That's dope.
Okay, I didn't tell you guys.
You didn't tell me that. Congrats, dude. Yeah, great. Dude, having a girlfriend these days, super rare thing, dude. The only girls I can get to talk to me have like kids and like baby daddies. So
Oh, nice.
it's a problem. Okay, great. Narosky, woot woot. That's dope. That is dope. That is dope. That's dope.
That's dope.
All right. I gotta go, but let's go say hi to someone. Who do I want to go say hi to? There's so many people streaming actually today. It's actually really cool. Maftia is doing. That's that. cool. Yeah, let's go say hi to Rocco. He's doing open science discussion. If you guys want to talk about science, go talk about science. All right, cool. All right. Enjoy the rest of your week. Have an awesome Thursday, Friday morning for European people. We will see you on Monday. Peace.
See you.
Sort of the relationship between science and society and a lot of the practices of the scientific community. Oh no, we're getting raided. Hey, Actual Education, welcome on in. I was just wrapping up, so welcome on in. Thank you. Let's do that. Yeah. Could have sworn that the 8 meant 8 minutes, not 8 hours. Yeah, I was, my SciComm streams do tend to go a while. 7-8 hours is surprisingly normal. Thank you for the hydrate, Suko. I do appreciate that. But, yeah, thank you for sharing your community. We were talking about open science today. Various open science practices, including open peer review, as well as open access publishing. So we were also, like, the first half of the stream was looking at a new research paper where the authors sort of noted that in a massive sample of published research papers that after acceptance chose to also publish the peer review documents alongside the paper were like 1/3 as likely to be retracted as papers that were published in these journals where after acceptance they chose not to publish the peer review commentary alongside the paper. There were also a lot of other interesting findings in there as well, such as sort of geographic distributions in open peer review practices, with countries like France